We welcome you to join us on this journey of how SegExperts is revolutionizing cervical cancer care with intelligent segmentation. Cervical cancer is the fourth most common cancer among women worldwide. Early detection is crucial for successful treatment. Traditionally, the pap smear test and liquid-based cytology test were used to identify cancerous and precancerous cells. But manual assessments are time-consuming and prone to human error, leading to the risk of missing positive cases. To address these challenges, the screening process has evolved towards automation. In the domain of cervical cancer detection, two primary types of automated systems currently exist. They are classification and segmentation. While both play crucial roles, our primary focus is on segmentation. Automated segmentation is very useful to extract important cell descriptors such as the area of the nucleus, cytoplasm, and N::C ratio, especially when the cell images have uneven staining overlapping cells. These descriptors are helpful for informed decision making of radiologists and enhanced classification of cervical cells into normal and abnormal classes. A multitude of techniques based on UNet and mask RCNN architectures have been applied for existing cervical cell segmentation systems, but these have major limitations. Existing segmentation systems face significant limitations. They rely on ground truth masks, which are labor intensive and time consuming to create. Additionally, these models often operate as black boxes, leading to skepticism among clinicians who are hesitant to trust and adapt these systems. This lack of transparency not only affects clinicians' acceptance but also impedes our ability to effectively debug and improve the internal workings of the model. Imagine a system where clinicians have complete transparency in critical medical settings. What if radiologists could generate segmentation masks for new cervical cell datasets without the task of manual pixel level annotation? What if experts could easily obtain cell descriptors such as N::C ratio to make more informed decisions? Clinicians and radiologists seek an automated system that offers not only accuracy but also transparency and interpretability, fostering greater trust and acceptance among practitioners. To address these needs, we proudly introduce our novel system, SegExperts. SegExperts is designed to overcome the limitations of the existing systems, providing a reliable, transparent, and interpretable solution for cervical cancer segmentation. SegExperts is built on a foundation of deep neural networks, explainable AI, and graph-cut algorithms, seamlessly integrating a range of cutting-edge technologies. SegExperts reinvent cervical cell segmentation, significantly reducing the manual workload for oncologists in outlying cancer regions. This leads to faster diagnosis and better treatment planning. Most importantly, it offers full transparency, greatly improving the confidence in radiotherapy. We don't just make these claims, we back them up with rigorous testing. We conducted an expert evaluation to assess the quality of the segmentation mask generated by our SegExpert system. In our expert evaluation, we tapped into the diverse expertise of 37 individuals in the medical field. This includes 9 seasoned practitioners alongside 28 enthusiastic medical students. Notably, 17 of these experts possessed extensive experience ranging from 1 to over 10 years in the cervical cancer domain. Their invaluable insights combined with the perspective of 22 enthusiastic individuals with less than 1 year of experience provided a comprehensive and inclusive assessment of our SegExpert system. This visualization displays the distribution of responses we obtain for nuclear segmentation. while this one shows the distribution of responses obtained for cytoplasm segmentation. These charts reveal that the majority of medical experts express satisfaction with our segmentation results, with only a small percentage reporting dissatisfaction, showcasing how SEG experts meets the expectations of medical professionals in real-world settings. Now, are you ready to see how SEG experts can transform image text segmentation? Let's begin the demo. Here is our SEG Experts web application. Our system offers a seamless solution for processing cervical cell images, delivering comprehensive insights through advanced algorithms. Our platform is structured into distinct pages: the landing page, the user manual page, configuration page, results page, and about us page. The navigation between these pages is effortless with our intuitive top navigation panel. The landing page serves as an introduction to both cervical cancer and SEG experts. Here, users gain insights into the application's features and functionalities. They can also kickstart the segmentation map generation process and access our user manual from this landing page. The user manual page provides detailed, step-by-step instructions guiding users through the process of generating the segmentation maps with SEG experts. Now, let's dive into the segmentation map generation process. Users can initiate this process by uploading the cervical cell images. Our system supports two upload formats: single images or zip file containing multiple images. Supported file types include PNG, JPG, and JPEG, and PNG. Alternatively, users can simply drag and drop their files. Upon successful upload, a confirmation message will be displayed. Then users can fine-tune the processing pipeline by selecting an XIM method and specifying the magnification value corresponding to their images. With a configuration set, a simple click on the Generate Segmentation Mask button triggers our null methodology for segmentation mask generation. So behind the scenes, SEG Experts leverages a combination of Flask API and sockets for backend operations alongside React.js for the frontend. Upon successful generation of outputs, our users are directed to the results page. Here, they can explore their results using two views, which are the summary view and detail view. The summary view presents original images alongside with their segmentation mask, simplifying analysis. For deeper dive, users can access the detail view, which provides comprehensive insights, including the segmentation mask, XAI heat maps, and detailed cell descriptor tables for each image. The segmentation mask delineates nucleus, cytoplasm, and boundary regions. The explainable AI heat maps overlay activation layers onto the original images, with the higher activation values are highlighted in red regions. Cell descriptor table offers a concise summary of key metrics such as nucleus area, cytoplasm area, and nucleus is to cytoplasm ratio, which were derived from the generated segmentation mask. To obtain their results, users can also download a zip file containing a segmentation mask folder with the segmentation maps, an XAI heat map folder with XAI heat maps, and a CSV file containing detailed cell descriptor information. Lastly, our About Us page provides insights into our team and our contributions to research in this field. Next, we delve deeply into a detailed exploration of the meticulously crafted pipeline that powers our SEG Expert system. Engineered with precision, this pipeline leverages a groundbreaking fusion of multiple cutting-edge technologies. This diagram shows an overview of our methodology. We utilize the HERLEV dataset which originally contained 7 classes. But for the scope of our study, we reclassified into 2 main classes, normal and abnormal. For data pre-processing, we resized the images to a uniform size of 224 into 224 pixels. To enhance the image quality, we applied a median filter for noise reduction followed by histogram equalization and normalization to improve contrast. And these enhancements helped us to extract vital information. To increase and balance the number of images in each class of the training set, we defined 8 sets of augmentations like translations, scaling, rotations, noise additions, and sharpening. Augmentations were chosen randomly and applied to the training images to ensure diversity. For classifying the images into normal and abnormal, we used VGGNet, ExceptionNet, and ResNet, all pre-trained on the ImageNet dataset. We froze the initial layers to capture the generic features while the latter layers were modified and trained on our dataset to capture the dataset-specific features. To evaluate the performance of our models, we used metrics like accuracy, precision, recall, and F1 score. Now let's discuss the application of the explainable AI methods, which is the crucial aspect of our study. We experimented with GradCAM, GradCAM++, and LRP to make our model's decision interpretable. And to evaluate the performance of these XI methods, we used metrics like image entropy and pixel flipping performance metric. Our first novel algorithm is CAM-based. The heat maps produced by the CAM methods effectively highlight regions within the cell nucleus and cytoplasm, which are key indicators of malignancy in cervical cells. We use the Gaussian mixture models to group the relevance values from these heat maps, creating segmentation mask that delineates the nucleus, cytoplasm, and the background regions. To further refine this segmentation mask, we employed the graph cut algorithms. By separately applying graph cuts to these nucleus and cytoplasm masks, we achieved more precise segmentation masks. Then, these refined maps were then merged to create a comprehensive pixel-wise segmentation map with improved clarity. Our second novel algorithm leverages layer-wise relevance propagation, which is LRP. Initially, the heat maps generated by LRP predominantly highlight the nucleus. To accurately delineate the nucleus segment, we cluster the relevance values into 2 groups. The initial segmentation is then refined using the graph cut algorithm. For identifying the cytoplasm segment, we begin by logarithmically scaling the relevance values. These scaled values are clustered into 3 groups, and the clustering is further refined through dilation. Concurrently, we create a nucleus removed image by applying a simple llama model to the input image and nucleus mask. Finally, we use these 2 processed images, the refined cytoplasm cluster and the nucleus removed image, and apply the graph cut algorithm to achieve a precise cytoplasm segmentation. Finally, we compared this generated segmentation mask with ground truth using dice coefficient and intersection over union to assess accuracy. With our 2 innovative algorithms and the SegExpert system powered by these meticulously engineered pipelines, you can streamline and automate your cervical cell segmentation workflow. Segmentation masks are now generated in seconds, eliminating the need for radiologists to arduously and manually outline the cancer regions. Additionally, users benefit from explainable heat maps and detailed cell descriptors, providing a trustworthy and reliable second option. It's time to embrace a new era of cervical cancer segmentation with SegExperts, where innovation meets reliability. For more details, reach out to us via the given email address. You can also explore our project on GitHub using the given link. Thank you for watching.